Good morning, physics class. I hope you are doing well. Thanks for meeting me yesterday. It was really good to see you guys. Isaiah and Nehemiah, I'm sorry we missed you. I realize you guys have stuff going on. I realize school right now is completely different and completely crazy, and I hope that everybody's figuring out a schedule that works for them, and you're able to get your stuff done for different classes and stuff like that. Hopefully, physics is going okay and we're still learning. So a few things we're going to talk about today with some of the different mirrors that we talked about yesterday. And I'm going to give you guys like a few examples right here. So I know I did this the other day, but I got a couple of them here. So we have this mirror, and this mirror is one that looks like that. So there's a couple things you can see and do on there. And I'm going to try to do it well so that we can see things. As we go through, guys, later today, I'm also probably going to post a Google Doc to Classroom. The Google Doc, I'm going to make it that everybody can edit. Because some of the times we're going to be doing some stuff, and like the other day the assignment was to do that thing with the spoon and send me a picture of doing it. But because some of the things I give examples of today, it might work well for you to try at home, and maybe there's somebody at home who can take a picture of you and your picture looks pretty cool and you want to share it with everybody else in the class. Please don't delete what anybody else puts on there. If they want to share it and do that, that's fine. If you want to add things, that's fine. Please don't delete anything. I'm going to post some things that are sort of important in there as far as a couple of the reasons things show up the way they do. But that way we can kind of have a running thread going as well. So look for that later today. And once in a while, probably in videos then from going forward, I'm going to mention, hey guys, you might want to check out the Google Doc. So anyway, a few things. One of the things I've seen kind of floating around sometimes is like how to not make yourself so bored while you're locked in your house. And it's like maybe spend some time with a friend, and they're like, and looking like that. Because like, how many people does it look like if you look in a mirror? How many people does it look like there are? Not just one, but two, right? And so I know this might sound funny, but they're also talking about how with all this stuff, we're supposed to be healthy and safe. And instead of shaking hands, maybe we're supposed to give high fives. So I think you know this anyway, but if we look at this and I go like this, oh yeah, my hand gets closer to my reflection's hand, and it's like one of them's coming like this, one of them's coming like this, and oh yeah, we meet each other, and there's that high five that's right there. So anyway, some crazy things that are going on with that. I don't know how well this is going to show up, but I got to use this is where I would say, somebody please come forward and help Ms. Jabs out. I'm going to move this down a little bit. And like if you both, this is one of those mirrors where one way it makes it look closer or different things like that, and the other way, this side is the plain flat mirror, which is the one I want to be studying. But this would be one of them where like if sometimes now if I would go like this, oh yeah, do you guys see how when I bring my coffee mug or my hand near there, you can see several, like it's not just two, but because the reflection of the reflection and stuff like that. And when you have that, you know, like you could do a little cheers to the last day of the first week of digital school, right? 4 days of school. Congratulations, guys. We're making it through. We're going to do it. It's gonna be okay. I know it's not the most fun, but we can do it. So anyway, how many of you sometimes when you're getting ready in the morning, I know it's something that I do, like when I wear my hair up in the bun, I want to make sure that there's nothing like sticking out all crazy, right? And if I'm looking in a normal mirror, like I'm looking in the camera right now, like I can't really see the back of my head. And so sometimes what I do is I use two mirrors at once. And I'm going to put this one up and back just because it's nicer to have the bigger one. Like when I'm in my normal bathroom doing this, I hold up this one on this side of my face because it's smaller. But like you hold up the one on this side and then you go back here, and with two mirrors, like maybe when you get your hair cut sometimes they'll go, oh here, how does this look? And they spin you around in the chair and they put the mirror behind you, kind of like where my window is right now. And then you hold up like this and you can see around. Again, I've mentioned it before, like if you go to a store and go into the try-on room, lots of times you'll see it where they have those ones that can fold in a little bit, because then you can kind of twist and turn and see how whatever you're trying on looks from several angles, because you know, sometimes you worry about those things and want those things to happen. So real quick, one of the things that I'm eventually going to post on that page that I'm going to share with you again, that's probably going to be posted later today. I think I might schedule, I always forget if I schedule something, I know you guys get an email, but if I just post it, do you get an email that says Miss Jabs posted something? So do you remember the other day when I talked about the thing called the normal line? Okay, a normal line is perpendicular to the surface. So if I move this down a little bit, again, here's my dining room table. That's what I've been working at the last few days. And if I would have this piece of paper, pretend that's pretty straight up and down, I think it is. But if I would put an angle down here, it would bounce up the other way on the other side. And if I would make a low angle like this, it would just barely bounce off this side like that, right? Now, the thing that's nice about a flat tabletop, if I would have a whole bunch of normal lines, it would honestly be like taking dominoes and stacking them up. All of the lines would be that way. So I'm just gonna make a quick sketch, which is why I'm gonna upload this to class, something like this later on Classroom. If this purple line is my flat mirror, no matter where I go, it's kind of gonna look like a pretty poorly drawn cone, but those blue lines would be all of my normal lines. But what's true about all those blue lines? They are all parallel. On a flat surface, on a flat mirror, excuse me, your normal lines are all parallel to each other. But then yesterday, if you were with us and we were looking through some things and looking at some of the different mirrors, okay, I don't know how well you can see this. Like, this is pretty cool. Oh, that's a really pretty cool thing right there. But if I kind of go this way, can you guys see how big my face looks? And again, if I go like this and like this, can you see how big my face looks in that mirror? I'll have to go back and look. I was trying to look through the video and it's hard to tell. Your face looks different. But again, I'm going to use the purple marker again to sort of represent the surface. So I know this is a weird picture, but do you see that curved surface with Miss Jab's face right there? I know, it looks just like me, doesn't it? So there's the curved surface. Does anybody remember if this is the way we're looking? What type of mirror would this be called? All right. If you look at your notes from yesterday, or if you were looking at that, remember when I said like the bowl is towards you? That's concave. The reason I remember that well is because I think about a cave, right? If you're going to a, like, let's just go explore that cave. Like, it's a little indentation and it's kind of on the inside like that. So concave. So this is a concave mirror. Now, this one is the flat mirror. Look at all those lines. They're supposed to be parallel. They don't necessarily look like it. But would you please look at this one? Remember, a normal line is perpendicular to the surface. A normal line is perpendicular to the surface. So if I drew a blue dot right there in the middle, you know what? Right there in the middle, the perpendicular line would look like that. Like if I zoomed way in right there on that one dot, would you agree that compared that purple line, that blue line, right there in that very small limited spot, looks like it's perpendicular? All right, but if I would move up here, and this is why it's kind of cool, guys, I get to use the camera like I just did, and I would cover up everything around it. Would you agree now, in order for me to think about being perpendicular, I would kind of have to draw along where my finger is right now. Again, if we zoom in on that one spot right there, would you agree that that purple line and that blue line look perpendicular? But look what happened with that blue line and that blue line. On a plain flat mirror, all of the normal lines are perpendicular to each other. However, on a curved mirror, the normal lines are not perpendicular to each other. And would you like to tell me, by the way, if I were to draw while I'm like moving the paper down here, I'm going to draw all of like a whole bunch of them, and it might not be a perfect diagram, which is again why I'm going to do that. You might want to draw something like this in your notes that we kind of made a little bit yesterday. What is happening to all of these bouncing off normal lines? They are coming together. Okay, the word coming together means the word that stands for rays coming together is the word converge. So if we were going to have a test on this, and the reason I said that, guys, is because I really have no idea how the next few weeks are going to go. But you know how like on the test that you guys were studying for that we were supposed to have a week ago today, and then all of a sudden we didn't have school. By the way, if you noticed in RenWeb, I did give you 10 points for studying for that test, and everybody got 10 out of 10, so everybody's score went up in the whole class. Thank you for working so hard, and I'm really sorry we didn't get to that. You know how on that test it was like when a wave hits a media change, some is reflected, some is refracted. When a wave goes to a new media, there's a new velocity. There was like fill in the blanks like that. This would be a fill in the blank right here. A concave mirror is a converging mirror. I wrote converger. Converge means brings together. So if you have a concave mirror, it is going to bend those light rays in, and they are going to come together, and they're going to meet at one spot in the middle. And I'm going to kind of show you that. I know you used a magnifying glass instead of a mirror, but how many of you have ever heard, like in the summertime, you can burn ants with a magnifying glass? That is because it is bending all those light rays together and focusing it on that one tiny spot. So concave mirror is a converging, sorry, I know I wrote converger. Those rays are converging together. Concave is a converging, means comes together. That's why all of these things are bending towards my face. And that's why that type of mirror works out the way that it does. If you give me a quick second here, because of those notes that I wrote on this paper, let's see, my mirror was in purple. So I'm going to draw my mirror in purple again. But then this one is going to be a convex mirror. Anybody remember convex mirror, what I said yesterday? And Nehemiah and Isaiah, I tried to tape yesterday's thing we were going to do, and it cut off halfway. I'm going to try to watch today how much we got and probably upload it to be able to like talk about that a little bit. It cut off in the middle because I had forgotten to delete my videos since they were already on YouTube. But this is a convex mirror, right? This is the one you see a lot of times in the corner of convenience stores or hospitals or things like that. And please remember, this is the one where I kind of had you, one time I said, look at the inside of your hands, look at the outside of your hands. When you were looking at the spoon, it was the top of the spoon, the side of the spoon. And so for this one, your face would be on the outside of the curve, okay? Well, if we think about this, and again, if I would put a tiny blue dot right in the middle of this paper, and again, sorry, I'm going to try. If I were to draw a perpendicular line from that dot, right, you guys know what the idea is now. All right, and then let me draw a dot up here, and then I'll do a few more. But if I were to do this, let's see, would you agree that right there I need to draw a line coming straight out the paper that way? But if you look at that, would you agree at that tiny little dot right there, that purple line and that blue line, hopefully they look pretty perpendicular to each other. And so I'm just going to add a few more of these. By the way, I believe you have been doing this for a long time, because anytime you were a little kid, I'm guessing, anytime you were a little kid and you drew a sun in the corner of the picture, didn't you draw something that looked like that with those rays coming off like that? You didn't know it. You were drawing a convex mirror, and you were drawing how the rays sort of bounce off of a convex mirror. Now, once again, what's true about a plain flat mirror? All the normal lines are parallel to each other. On a concave mirror, all of the rays are converging. Guys, I know concave and convex. That's why I have to be careful. Like, don't stress the con so much. This is a convex mirror. Okay, convex because of the way it's curved. So don't just think concave means converge, because convex does not mean converge. Remember, converge means they're bringing them together. What is happening to these rays? They are spreading out. They are not coming together. Converge means come together. Oh yeah, what's that called? The opposite of converge is, so a convex mirror diverges the light. Okay? A convex mirror diverges the light. And I know on my other paper, I just wrote converger. It converges the light. Which is why the last few days, when I've been holding up the mirror this way and I was like, oh guys, that's really, really cool. Okay, because I got to make sure I have the curved side. And again, remember yesterday when I did that on the video and I was like, can you guys tell that this is curved? I'll use my little chapstick. If I put this in here, can you guys really tell that this is curved? Oh yeah, a little bit. You'll see that settle in the middle. But if you remember the curved mirror I used yesterday, it was so curved, like that marker was rolling back and forth. You see this roll back and forth a little bit, but then it just, you know, it's not as curved, but it is. Oh yeah, here's Miss Jabs being the nerd. Do you guys see this little like weird thing that's showing up on Miss Jabs' face? And some people think, oh, I can get that when I have my watch. But do you see all this crazy light bouncing up right here? Okay, we're gonna see how well Miss Jabs can do this. Do you see that right there? That is not just like a whole blob of something. If I spent my time, and I think with this one I need to back way up. I'm almost there. That is actually a pretty clear diagram of my, hold on just a minute. There we go. That's even better almost. Guys, look at the paper right now. Was it pretty much the same? Let's see again if I can get it a little bit better. Because I'm going to have to stand up, I think. Isn't that kind of cool? Now just imagine if we were in school together and actually able to do this together. It's really pretty cool, which is why I know you guys, a couple of you told me, and I'm not mad. If you have one of these mirrors that's like this double-sided mirror, there's some really cool stuff we can do. So I'm going to leave us at that because it's kind of cool to just cut off there and make you think about it a little bit. I miss you guys. Thanks for doing Hangout yesterday. Bye.